I've been told that if there's a lot of people, you should make room to get them into the center of the room, but I don't think that will be a problem. So we'll just start normally. My name is Yngve. I'm a developer in the IncludeOS open source project. I'm also on Twitter. That's my handle. And when I checked in to my hotel, the receptionist told me that that last name was way too hard. So I'm sorry about that. I blame my parents, but Google will probably help you find me. I work for IncludeOS, and hopefully you have seen some of the other talks. There have been at least 3 talks, and if you missed some of them, they will be on video soon. This talk, although I work for IncludeOS, this talk is not about operating system development, not about systems programming, or any low-level difficult stuff. There will not be any inline assembly here, so I'm sorry to disappoint those who like that, but I think there's a talk about assembly on Friday. If everybody could check that they're in the right room, this is the theater, and the time seems to be correct. You probably can't read that, so I enlarged the portion there. You see down there where it says level beginner. I've seen many of you around, and I doubt that there are many beginners here. Hopefully, some of this content will be useful to you anyway. There are probably beginners in your companies or in your user groups or something. Teaching and learning has kind of become the unofficial theme of CppCon this year. There have been many sessions about those topics, starting with Bjarne's keynote on Monday. There was also a trainers panel and the academia panel and so on, and I just want to tip you about this. It's later today, teaching related, and looks very interesting. This talk is about tools and techniques for staying up to date with modern C++. And C++, we have lots of everything. It's a big language, it's a big ecosystem. We have lots of tools and we have lots of techniques. Clang Tidy, Valgrind, Clang Format, Core Guideline Checker, and Visual Studio, all good stuff. Also, techniques. I don't know who comes up with these names, but substitution failure is not an error, and the curiously recurring template pattern. If you know what these are, you're not beginners. As programmers, we tend to prefer hard topics about the technology and how machines work. This talk is unfortunately not about that. It's more about soft topics like people and how we work. This is a really hard word. What it means is self-education. Education without guidance of institutions or teachers or masters or professors. I want to talk to self-learners, people who have some C++ or programming experience and want to learn how to stay up to date with modern C++. Bjarne said this on Monday: teaching is easy, getting people to learn is hard. That's true, but people really, really want to learn. The most popular online course for several years running has been a course about teaching yourself how to learn. Bjarne also said you should know your students. Most are not like you. And that's probably true if you're a college professor, but if you're self-learning, obviously, your student is you. It's kind of important to make your learning process as effective as possible to know yourself. Bjarne also said that the previous occupation of most professors was student, and that was maybe not optimal, but imagine how confusing it is when you try to be both at the same time. You are your own student and your own professor. I'm going to share a bit about myself. Like probably most geeks, I'm not really comfortable talking about myself, but for this work, you have to know something about me. I never intended to go into programming. Like many people, when I grew up, I had no idea what I wanted to do, so I did the obvious thing. I studied business administration. So this was in the 90s, and even then you still had to have some technology courses in your curriculum. We had to take 2 IT-related courses, and I took one called structured programming and one called object-oriented programming. This was the textbook we used, C, How to Program, great title. This is the 2nd edition. This book is still in use. They're now up to the 10th edition, I think. It starts with C, and then the second part, or roughly the second part, is C++ as a better C. So it starts with the low-level C stuff, manual memory management, and then when you get a bit further, you get to the C++ part, you learn about object-oriented programming. One of the classic examples, you implement your own string class and so on. And like I mentioned, this was in the mid-90s, and C++ was quite different then. They also had this classic book as suggested reading. And this was in a simpler time before the internet, and where buffer overflows was not a huge problem. So we had static-sized buffers, and we never cared about overflows. I must have become somewhat interested in programming because I actually ended up buying this book. And from this angle, it doesn't look so intimidating, but if you flip it around, you know it's a pretty heavy book. And I have to be honest, I never got past the iterator chapter. That was too hard. I think I must have understood a couple of things because on Bjarne's homepage, he publishes errata for printings, and I'm actually listed there. I cannot remember what I told, what kind of error I found, but it probably was some minor thing. I see there are also some other celebrities. And Kaiser Soze, I don't know if anybody remembers the usual suspects, but I think it makes sense. If you are a supervillain, you use C++. Anyway, like I said, I had no intention of going into programming, so I started working in media production. First I did print work, then I did corporate videos. Then I ended up with doing multimedia, web, and apps. So obviously, the future got more and more technological, and I figured it was time to go back to school to get a proper CS education. And I ended up studying under this guy. I don't know if you've heard about him, but I've seen him around, and I think he knows what he's talking about. Ended up having to get a newer edition of Bjarne's book. This time I actually got through the iterator chapter. That was pretty good. And the funny thing is, this is still recommended reading. So my 20-year-old copy has served me well. One of the things about C++ is in college, it's not taught in isolation. Technically, it was a C++ class, but there were a lot of different topics that were put into that class. You have the basic language, you have the standard library, you have low-level bit access stuff, and you have high-performance stuff, object-oriented programming templates, and all these other things. Plus you have all those workflow things about linking and make files and things you don't need to worry about in other chapters. And it's kind of weird that so much C++ still deals with these low-level things. But again, it makes sense. I'm sure if you ask some database professors, they will complain that you don't learn SQL properly. But there they also have to put in a lot of real-world topics like data modeling and transactions and normalization and all these other things. So there are usually no college classes for wannabe language lawyers where you go perfect detail into a language. You use a language. Okay, now you know far more about me than I'm comfortable about. The reason for that is if you are interested in self-learning, you need to do a self-assessment first. You have to know how you learn, what kind of material that works for you, what kind of material you don't find interesting, etc., etc. Here's a slide, and don't worry if you can't read that, because that's not the point. This is a very, it's internet famous Stack Overflow question, and it's a BMI calculator, and the first version there is, I would call it old school C++. You have explicit control structures, you have the switch and all that stuff, lots of if and else ifs, and that's the way I was taught C++, and that's the way my brain, if I get an assignment to make a BMI calculator, that was what I would do. But it's not what you're supposed to do. This is a good answer. It's been discussed quite frequently. And as you see there, you use upper bound from stud algorithm. And this is a lot more elegant. If we go back, you see here, it's probably is a lot longer. It's easier to make mistakes. And it has far too much details about unimportant stuff. It tells you how to do it, not what you want done. And to take another example, this is a snippet from the aforementioned code. This is from the explicit control structure version. And I find that very readable. Variables are named, they're explicit, you probably understand what's going on. If this had been the sample code, with variables named foo and bar and bass and all those things, then I tune out immediately. If a textbook has functions and they're called f and g, I lose interest immediately. If they are called the calculate sales tax, then hey, I can understand this. Okay, the point of this is the kind of thing you need to self-assess. I am clearly more familiar with explicit control structures. I am bad at recognizing opportunities to use the standard algorithms. I have a very low tolerance for abstract code examples, etc., etc. This is important because we need to maximize the return on investment when we are studying. There are many different ways we can study, and again, this is not for school study, this is things you do on your own, self-directed. So here we have a lot of different activities, and we have effort. And if you start on the left side there, you can start a project on GitHub or read a blog post. That's pretty low effort, but also a pretty low reward. Then you can exert some more effort. You can go to CppCon. You can hear lots of, hopefully some of them useful talks. Or you can try some code in an online compiler. But that takes more effort. Then you can do even more effort. You can write a blog post where you explain something, or you can present at CppCon. I really don't recommend that, or you can write a standards proposal or write a book. And if you were in the trainers panel, writing a book is not considered worth it either. The thing most humans, at least realistic humans, we try to follow the principle of least effort. Here, I have a pen. If I walk around on stage and I accidentally drop it, I could go back like this, charge forward, somersault over there, slide down there in the crowd, jump up, but I'm not going to bother. It's a pen. It's going to stay there until I pick it up. So I want that pen when I go home, but it's going to be here, and nobody of you are going to come up here and take it from me. So you have to use the least effort that will accomplish your goal. And that goes for training as well. We're going to do a slight detour. I don't know who Eduardo Madrid is. It's a really cool name, and he seems to be here. So if anybody run into him or know him, say hi to him. He is really, really enjoying CppCon. And from his description here, it's like drinking from a fire hose. Each presentation takes days to digest, and there's a bit of FOMO, fear of missing out, because probably when you're in here, there could be at least 2 talks at the same time that are even better. 5 in this case. And I don't want to be a Debbie Downer, but anybody here familiar with imposter syndrome? I'm asking for a friend, of course, but good to know. This is pretty much how I felt when I got back from CppCon last year. And it's important to have some balance. So what is imposter syndrome? Basically, and this is oversimplified, 2 things. Inability to internalize accomplishments and a persistent fear of being exposed as a fraud. This is incredibly common. Here are just very, very few people. They have written very well about this. And these are celebrities in the programming sphere anyway. I mean, John Skeet is like the superstar of Stack Overflow, and he has written about this problem. And the thing is, with these guys, obviously, they have to be imagining it because you know they are really excellent programmers. But me, on the other hand, So just to cheer you up, some reassuring words from Simon. Don't be discouraged when you find things difficult. C++ is hard, and even the experts get things wrong. So having said that, we need some information sources that we can use when we need to follow modern C++. Are you familiar with Sturgeon's law? It's not all the information out there is equally useful. Plus, there is really a lot of it, and it would take, even if you found only the perfect, really good, flawless information, it would take a long time to process it. Here are some potential sources if you want to know what's going on with modern C++. And we are going to put them into categories good and bad, and that doesn't mean on an absolute scale. That means good or bad for the specific purpose of paying attention to what is going on with modern C++. We have the C++ Slack. It's great when you're at CppCon. It's very nice to ask questions there if you're stuck on anything, but it's really noisy. And people there tend to be fans of doing things harder than you have to, just for sport. Another really useful source is the committee mailings. Available online, papers, proposals that the committee will discuss and consider for standardization. This is one, probably the most recent one. But it has way too much detail. Again, on the return on investment thing, if your goal is to be a language lawyer, if your goal is to have 1 million points on Stack Overflow, then you should read these. But if your goal is to stay up to date and be reasonable confident, this is overkill. Now, how about Reddit? Reddit has kind of an iffy reputation, but the C++ Reddit is surprisingly good. The moderators are doing an excellent job. Generally, quality content flows to the top, and they are very pragmatic. It's useful, or most of the content is useful and not language lawyerly. So I recommend that. Twitter. That's, of course, a perfect place when you're looking for snark and political fights and lots of time wasting. But if you have been at CppCon this year, last year, you will know that a surprisingly high percentage of C++ developers, or at least the kind of developers who go to CppCon, are very active on Twitter, and they post so many good links. So I would recommend following quite a few of them. There is this guy, some strange Norwegian guy. He has created a Twitter list where he has hundreds of C++, of the best C++ followers. So I recommend subscribing to that list. Of course, we have Meeting C++. Every week, I think, they publish a blog roll, which are a collection of blog posts that they have tweeted on their Twitter channel or something. It's really good anyway. This is one of the latest ones. They change every week. Very nice curated list. Of course, you have CppCast, goes without saying. It's the best podcast ever. And then you have a very useful concept. I don't know if these are collected anywhere. Back on step 2, where we have the committee mailings, these are the raw papers from the committees. Then we have people who go to the committee meetings who write, it's a C++ specific genre, they write reports from the committee meetings. They digest the papers, they give highlights, they explain things. It's tremendously useful. I don't know if there's a collection of the trip reports, but if you follow the Reddit CPP, most of them are posted there. They are really, really good. They are much more approachable than the raw committee mailings. Highly recommended. I think Andy is right. C++ was invented primarily to teach humility to humans. So it seems like he and Simon are in agreement. And if you are discouraged, because every now and then you will be, you can just remember what the legendary Japanese director Akira Kurosawa said. I've been able to work for so long because I think next time I'll make something good. Okay, we should get back to modern C++ and how to learn that. And here's someone named Perry. He tweeted a couple of weeks ago, C++ 17 approved by the Standards Committee. C++ 20 work already started. Once the language gets more features, it will finally be perfect. And I felt that this reply summed up my feelings pretty well. Okay, but what is modern C++? Can anybody define that? This is frequently debated, and nobody has a textbook definition, I think. But what is modern C++? Meeting C++ is, again, they have tremendous resources. For example, the Twitter feed there are usually very insightful polls. And they found out that a majority seems to be using modern C++. And this is, of course, a majority of C++ users on Twitter. That is not representative of all the C++ users in the world, I think. But there was a follow-up. The link is up top there. And modern C++ seems to be a name for C++ written to C++ 11 and later standards. I don't know if you agree with that, but it's a useful definition. Another definition that's sometimes used is modern C++ is code that follows the C++ core guidelines. I actually printed the C++ core guidelines before I came here. And in Europe, we use paper called A4. It's slightly different from your letter size paper. But the core guidelines, when printed, are 340 pages.
You printed on both sides?
No, I printed single-sided. And if you have to read 340 printed pages, and that's just the core guidelines, then it's tough to know what modern C++ is. So modern C++, it's kind of the thing where you know it when you see it, but you cannot really say what it is. But we have a great example of what modern C++ is not. Patricia Aas had a great presentation about 2 weeks ago, C++ for Java developers or Android developers, I'm not sure. And this is not modern C++. Raw pointers, manual memory management using operator new. I think most people would agree that even though we don't know what's modern C++, this is old C++. Okay, now we're going to have to talk about something a bit scary. What is the scariest thing you ever read? For me, personally, it was an email subject I received in July. But that was hopefully just a one-time thing. So what's the scariest thing I read regularly? It's this 3-line simple recipe. To install library, configure, make install. To make it even scarier, when they have sudo make install. There are basically C++, since it has a history, it's used for systems programming, and it has roots in C. We often talk about the system compiler. We have system libraries. We have system include paths. There's one, and belongs to the system. Newer languages have package managers and virtual environments, so you can have one setup per project, which makes sense. But in C++, it's common to have one setup for the whole system. We should have a way to work around that. And I don't know if this is the best way, but it works. We use Docker. You want to have your dependencies, and you want to perform your build inside a controlled environment. Everything happens inside a container. Nothing gets installed on your actual system. Nothing gets left behind. There is no pollution. And everything is kept nicely separated. So for example, in IncludeOS, if you want to build IncludeOS services without installing anything, no development tools, no environment, then you can go here, and we have Docker containers to build and to test IncludeOS services. Or if you just want to, let's say you are using a version of Ubuntu where GCC version is 4.9 something. That was the most common version in a recent poll. Let's say you read a great article about something new in GCC 7, and you want to try it. Then this is a very useful thing to do. Here we have two commands. The first one, Docker pull. That will fetch a pre-made image which has the latest version of GCC. And the second one, that runs that whole environment like a normal executable. And the command line looks a bit confusing because you're usually not adding all that stuff when usually you just use the last 3 or 2 words there, GCC source CPP. But everything here happens inside a container, so there's no pollution. And someone named Jan has written a really helpful and nice introduction about this. You can just copy and paste his examples, and you can test code in GCC latest 7 without installing GCC. It's great. There are also many other pre-made Docker environments. Here is one where you can select between Clang, GCC, and some other compilers. And the workflow is pretty much the same. You pull an image that has the environment you want, and then you use it using a slightly convoluted command line, but nothing gets left behind. The LLVM project actually has great documentation for building. Let's say you want to build a more recent version of Clang than what your distribution is delivering. You should go and check out this link here. This gets even more exciting if you start building your own Docker containers. Unfortunately, that needs to be a separate talk, so you could look at the Docker images from IncludeOS. They are on GitHub, open source. You can use them for inspiration. And if you want to chat with us, we have a Gitter chat room. It's like Slack, only Gitter. Okay, so now we have covered 2 objections to, or 2 things that make it difficult to learn modern C++. First of all, information overload, but now we know how to select useful sources. And the second problem was the thing about dependencies or compiler versions. We just move that into Docker. It's like our own sandbox. But that's just things we need to start learning. We haven't learned anything yet. Kevlin Henney, he is probably one of the 10 smartest people in the universe. And he has said that the act of describing a program in unambiguous detail and the act of programming are one and the same. We can exploit that by doing something most of you think is really boring, but is tremendously useful. You can write unit tests. Unit testing is perfect for learning. You have to state what you think should happen. This improves our intuition about how the code will work, and it teaches us about potential problems. It's bite-sized. You can test one minor thing at a time. You can be as granular as you like, and you get to test edge cases. How many of you can say unambiguously what will happen if I have a vector, it's empty, and I pop from it? It's easy to find out if you write a test. This is a presentation. It's about 10 years now since it was recorded, so the video quality is somewhat depressing, but I highly recommend watching it. Kevlin goes through unit testing in C++, and you probably know that obviously people have always done unit testing, but for a while it didn't exist as a name or as a concept. But then at first the Smalltalk people started doing it, and then the Java people picked it up with JUnit, and then people obviously ported the JUnit. We had NUnit in .NET, and we have XUnit or whatever in C++. And the problem with that was that your code looked like and felt like Java. You had to write a lot. You had to make classes for everything. You had to write convoluted search syntax. It was boring. But with modern C++, and this is what Kevlin talks about in this talk specifically, is when you got to C++ 11, you've had the facilities to write unit tests in a much more C++ idiomatic fashion. So it didn't look like or feel like Java anymore. This is a repository on GitHub, which has a comparison of multiple modern C++ unit testing framework. I think Catch is probably the most used currently, but all these are really, really good. I personally use Lest, but the difference between these frameworks is not huge. Here is our first test. That's what we need to figure out how structured bindings work. And how does it work? Really badly, because we always write a failing test first, because we want to know that our setup is working. Then we fix the expectation, and this will pass. This is so simple, and now you know the basics of structured bindings. So then you think, hey, that works for a tuple. Let me try doing that with a struct. So you write a new test case. You create your structure, and you create some variables, and you use it, and you make sure that your expectation matches reality. This is fun. I know it doesn't seem like it now, because now you see pre-digested tests written here, but when you're doing this yourself, and you're exploring code and getting immediate feedback of what works and what doesn't work, this is really helpful. Okay, now we figure out, okay, structured bindings, fun. Can we update the struct? So again, we unpack the variable into individual variables that are declared at the call site. And since we use an auto reference, we try changing it to a new value. And we expect that the new value is not the same as the old value. And again, this does not work really well as a slideshow. But if you try doing this for half an hour, you find something you don't know, you write 10 simple tests, I'm pretty sure you will enjoy it. You should do the simplest thing that could possibly work with this important caveat. Okay, the technology world changes really, really quickly. I submitted the proposal for this talk in June, and in it I mentioned some things I was working on in the spring. We were working on getting started example for Docker, libclang Python script to take a library and create a single header file version of the same library, and a libclang Python script to generate outlines of libraries. As you have seen, last week, Jan published a blog post that covered that really, really well. And about 2 weeks ago, Vittorio Romeo wrote a Rust program, but we forgive him for using the wrong language. It translates libraries into self-contained single header versions. And finally, if you have been downstairs, you will have seen this poster. I stole this picture from a blog, but this is SourceTrail. They are in the poster competition. You should go look at the poster and examine this. This is much more useful than anything you can make on your own. And the license is really inexpensive, so I recommend that. So all those 3 projects were overcome by events. But the good thing is they were overcome by better things than I could have made on my own. Unfortunately for you, that means that this talk got a little bit shorter than it was supposed to be. But now you can relax, go out, enjoy some sunshine, but remember to come back for Christopher's talk in about 2 hours about teaching and learning C++. It's up in 4:07, I think. Are there any questions?